So I'm sure that other presenters will sympathise when I say, you get this schedule from Elizabeth when you're going to talk, and you open it with trepidation, and you go, as long as I'm not after lunch on day 2. So I shall try and make this snappy and alive and to keep us awake on the last trip in to the end of the session. So cycle lifts, and this topic came about really off the back of Len's presentation last year, which I thought was fascinating on goods lifts, where you have a subject that might appear on the surface to be quite mundane, but actually has a lot of issues associated with it and a lot of problems. So we went away and started thinking a bit about cycle lifts. And I guess in the old days, and there won't be many, if any, of us in this room that can remember these days, life was a bit simpler, it was a bit slower, a bit more calm and collected. And lots of people travelled like this, on bicycles. It was the most common, most cost-effective form of transport. Then this came along, the car. 4 particularly beautiful examples there, I think. So all of a sudden, all of those started to become affordable, and everybody, all of us obviously said, well, that's far more convenient, I can get where I'm going much quicker, I'm going to abandon my bicycle, I'm going to start using the car. Then this started happening, congestion. And I guess the other associated issue with that is pollution. And all of a sudden that convenience of the car and our ability to get from A to B quickly and easily and comfortably was actually starting to wane again. And certainly in big cities, we're kind of seeing this happening a lot more. People are starting to use the bicycle again. And it's happening not just because of car use and congestion and pollution, but I think it's also aligning with this general appreciation of health and well-being and the need to actually exercise as well. So we look at that and say, well, what's that got to do with lifts? It's interesting, but that's all about transport. It's got nothing to do with lifts. And I think that the problem is initially illustrated by this. So these are 2 graphs showing cycle use. And the one on the left is in the UK, looking from the years late 1940s here through to 2014. And you can see back here just how prevalent bicycle use was. 14 billion bike miles in the UK back in the late 40s, early 50s. And then as the car became prevalent, it went down like this. This graph on the right-hand side focuses in on the most recent period of time, from 1977 through to 2015, in central London. And you can see what we're starting to see, certainly in the last 10, 15 years, a very significant trend in bicycle use in central London. And I'm sure I'm seeing evidence that this is being replicated in big cities and conurbations throughout Europe and throughout the world. Why is it still important for lifts then? Well, we've got storage issues. We need to do something with these bikes. When we arrive at buildings, where the hell are we going to put the damn things? Not quite as expensive as this, clearly. So I think we're lucky in London because we had some very good advice that started to give us some guidance and some benchmarks on how to design for cycles and cycle use. And this came from a very shrewd and learned gentleman a few years ago. We've now, well, many of you, we promoted him out of trouble, and he's no longer the Mayor of London, he's now our Prime Minister. But one of the things that he started to put in place was something called the London Plan. And it's currently now at a new draft out for comment called the Draft London Plan. And the London Plan talks about many, many different things to govern and guide and enhance development of buildings and the built environment within London. The current Mayor of London, Sadiq Khan, is a great proponent and supporter of the Draft London Plan. And he's made this quote recently. So, I see the London Plan revolutionising the way we get round our city, enabling a boom in active travel, with walking and cycling becoming the primary default choice for millions of Londoners, because we made it far easier and safer. So there's a real political urge to encourage and facilitate the use of bicycles. And we're certainly seeing that again in London with a lot of cycle routes. But what it does do, of course, is it gives us some issues as designers and planners, because policy T5 in the Draft London Plan starts to talk a little bit about how do you design appropriate cycle parking. Some obvious comments there. It says it needs to be fit for purpose, secure and well located. It says it needs to meet the current demand, but also future demand as well. So when we start to think, well, how do I quantify that? The London Plan, this is an extract from far more detailed guidance, but it starts to provide some guidance here in terms of the quantities of spaces. The key thing probably to think about is here is offices, which typically generate, and they're the largest types of buildings. And the London Plan at the moment talks about having a bicycle space for every 75 square metres of gross external area. So that's quite important. One space per 75 square metres of gross external area. And we'll look and see in a minute with a case study just what that can mean in terms of numbers. It also talks about cycle parking permitting easy access for disabled cycles. So it's not just about bicycles, it's about tricycles or non-standard adapted bikes. And that starts to become important when we start to think about how much space does it take to accommodate a bicycle. And then the London Plan also makes reference to this document, the London Cycling Design Standards, which again is a useful document for us as designers. So the London Cycle Design Standard talks about we may require the provision of shallow ramps or lifts large enough to carry all types of cycles. And it says to accommodate these types of cycles, lifts should have a minimum dimension of 1.2 by 2.3 metres and a minimum door opening of 1 metre. Kind of sounds quite good. But then you start to ask yourself a few questions. Is that 1.2 by 2.3 or 2.3 by 1.2? Does it matter? And how many bikes with their riders can I get in that size lift? Is it 1? Is it 2? Is it 3? Is it 4? What is the rated capacity of that lift in terms of bikes and riders? This doesn't tell us. So what is the minimum size I need to accommodate 2 cyclists, 3 cyclists? Important stuff. And probably most important, what's the demand? So we've heard and talked a lot today about traffic, today and yesterday about traffic analysis for passenger lifts. These same principles are now starting to apply for cycles. How are we going to move them in and out of the building? How big a lift do we need? And how much are they arriving? So I thought I'd turn to BCO. I thought BCO maybe will help me clarify some of these things. And BCO did have some guidance in there. So quite obviously it says required where levels either above or below ground are provided with significant numbers of motorbike and bicycle spaces. And it says the car configuration is at least 2,300 millimetres deep, with entrances on opposite sides. So that's helpful. That addresses maybe one thing, that it's kind of saying we should really be trying to make these lifts deep rather than wide car configuration. But it still leaves a whole load of questions kind of unanswered. So I thought with my Guide D chairman hat on, I'd go and look at Guide D, because normally Guide D is a wealth of information. So I went to Guide D. This is what Guide D says on cycles. Quite unusually, and as chair of Guide D, quite embarrassingly, I thought. But Gina made the very good point that Guide D, if you think the last one, was published in 2015. So the input and guidance was rewritten probably in the 18 months, 2 years prior to 2015. So whilst cycle use was starting to become more and more prevalent and visible, it probably wasn't at the level that it's at now. And certainly with the 2020 guide being published next year, there's a real opportunity, which Gina has given me, to incorporate some of this guidance maybe, plus comments from peers, into the 2020 guide. So at least we start to have some consolidated guidance in a good objective book on cycle lift demand. So we've looked a little bit about what's out there at the moment in terms of guidance. I thought it would be useful to share with you one of the case studies that we've had within Swaco, and hopefully it will illustrate the scale of the challenge and why we think it's important for big buildings. So this building is Elizabeth House in London. You can see the building here. This is obviously a render in red here. So here's the London Eye, houses of Parliament, Big Ben, shrouded with scaffold. It's a big building. Now, if you think back to that idea of 1 per 75 square metres gross external area, we've got in here 1.2 million square foot net, so over 2 million gross external area. This building, the London Plan cycle provision, generates a requirement for 2,500 cycles. Almost the entire half level at basement 2 is cycle storage. And then you've got the associated showers, changing rooms, lockers to go with those numbers. It's a huge, huge number. But then we go back to this question about, well, they don't all arrive at the same time. Yeah? How do we get a sense of designing for that demand? So we looked at, sorry I should have said there, in terms of design team, very important design team partner here, the transport consultant. So as lift designers, we're saying we don't really understand how people use bicycles. We understand how people use lifts, but we don't understand how people use bicycles. Can you tell us, give us some information about the demand? How will people arrive at this building? And some of the conversations we've had with those guys, I'm sure people in the room have similar conversations, that demand profile is heavily influenced by the location of the building. Here is Waterloo Station. So that will influence in terms of whether you choose to take the train or your bicycle. You've got the river, you've got cycle routes, lots of things that will influence that demand. This is what we got from the transport consultant. So here is a theoretical demand. This is 7 o'clock in the morning through to 10 o'clock in the morning. So they were saying that the peak demand will be arrivals in the morning, which kind of feels right. We'd certainly say lift-wise, passenger lift-wise, you've got a morning peak, you've got a lunchtime peak. The lunchtime peak probably isn't relevant in bicycles. You're going to go out and get your lunch and come back, you're not going to necessarily go and get your bike. So the morning peak felt like the right kind of profile. But when you start to look at some of these numbers here, so these are 15 minutes, we've got 180 bicycles arriving in a 15-minute period. So that's quite a big up peak there. 60, 65 cyclists and riders arriving every 5 minutes. So then we start to think about how big a lift do we need to accommodate these riders. And again, we went back to the transport consultant and said, give us your views. You know more than we do about how people use bicycles, how much space they need to be able to get into lift cars. And the conclusion of that discussion was that to accommodate 2 cyclists and their riders, you probably need a lift car somewhere around 1.4 by 2.3. So looking at EN80 120, that's about a 1425 kilogram lift. It's quite a sizable lift. You take that for 3 cyclists and riders, it starts to become a much bigger lift, about 2.5 tonne now, just to take 3 cycles and riders. So we tested this against that demand profile, and we're quite surprised when we started testing using simulation software. So this is putting that demand profile in the morning against 4 of those smaller lifts. So each of the lifts being able to take 2 cyclists and riders. All the parking is at one level at basement 2, about 10 metres below ground. There's no other stop, so it's a shuttle service down essentially, so fairly efficient. But you can see with 4 of the smaller lifts, the system is saturated. Queue lengths are just coming out them. And certainly from a planner's perspective, the planners are very focused on any development having sufficient space within it to accommodate any queuing traffic. They don't want cyclists queuing out into the public realm. So it's important as part of the planning submission that we can demonstrate that our cycle lift provision is appropriate to deal with that prevailing demand. So clearly here at 4 of those smaller lifts, it isn't. That quite surprised us. But then we kind of look back at that simulation and think, well actually, every time the lift loads, it's only taking 2 cycles away. So we looked at the larger one. So 4 of the larger lifts that could then take 3 cycles and riders. And that transforms it. So then, clearly I suspect we were right, very close to that saturation point with the 4 smaller lifts. Make it 4 larger lifts. And I guess you're now taking 3 cyclists every time the lift departs rather than 2. The waiting times come down, but probably more importantly, the queue lengths come down dramatically. So this is anticipating peak queues of around 10 to 14 cyclists and riders, which kind of starts to feel a bit more realistic and a bit more manageable compared to where we were before. So then we've got to look at the environment to sense, well, is that manageable and realistic? So this is a plan, a general arrangement drawing of the ground floor. And you can see over here is the core in question. So this is the entire building here. So it's a big, long building. If we zoom in, so this is the street here, and this is the proposed architectural design with entrance in off the street. Here are the 4 cycle lifts, and here is a lobby for the cycle lifts. So we were obviously very conscious that we could not, or we could, but we should not, ever use that circulation route as a lift lobby, particularly if it's not just people waiting, but it's people with bulky bicycles as well. So that started to look quite good. We've got our cycles there, we've got our lobby there, and our throughput here. And then we tested it against the space. And again, talking back to the transport consultants, this was their proposal in terms of the space allowance that a cyclist and rider needs. So I guess it's a bit analogous to the 0.21 square metres that we might use in passenger lift traffic analysis in terms of how much space a passenger needs in a passenger lift. This is the proposal of how much space a cyclist would need in a lift or in a lobby. So with queues of around 12 cycles, that's kind of generating a lobby area of 24 square metres as a requirement. Obviously these are quite large lifts, so that lobby is meeting that requirement, but it's quite sizable space. And I guess, moving maybe to conclusions and recommendations, I know Elizabeth House is quite a large building, but the principles hold, I think, for any significant development. That bicycles are large, bulky things. Their use is becoming more and more prevalent. The demands that can be required by planning are becoming really very, very significant. And therefore they're a real focus for good design to make sure that we get it right. I've got some conclusions and recommendations here that I'd welcome any challenge or refinement from peers and colleagues, because I think these are the kind of things that we ought to strive to get into Guide D. So at least we have some sense of principles that we're all going to design around. I would suggest that cycle lift capacities are assessed in accordance with Table 1 in the paper. So that's a document that proposed certain lift car sizes for certain quantities of cycles. We used in our traffic analysis a transfer time of 2 seconds in each direction as an average. That might be a bit optimistic, I don't know. But again, I think the other key point that I'd like to make is this call for real-world survey. I think there's a real opportunity to go to a busy established building and look at the cycle lifts. Are they being used as they were intended to be used? Of those 2,500 spaces that we had to provide in the design, are they being used? Or are 50% of them empty? Through car, I think it's got to be a good idea. It's got to minimise transfer times and interference between people coming in and out of the lifts. I'm proposing here an average waiting time of no more than 40 seconds, but certainly in the design work we did, it's not the waiting time that's the key thing, it's the queue lengths. If you get the queue lengths to a manageable level, then the waiting time will naturally follow anyway. And then I think all cycle storage and associated facilities at a single floor level. We do work on buildings where you've got cycle levels at one level and then the showers at another level and the lockers, and that just, you can imagine if that shuttle lift system wasn't a 2-stop system but a 3-stop system, that's going to further erode our traffic. And then the final point, just in terms of water ingress. So hopefully you'll agree that that is a useful set of information and seeks to try and establish some kind of design criteria that we can use, challenge, refine as we see fit, but starts to take a step in the direction of getting some kind of consensus on good design for the transport of bicycles. Thank you.